All right, guys, welcome back. So we continue the lecture series from where we stop. Then we look at today. We start from the language syntaxes and data types and operators. So what are the syntaxes? What are syntaxes? What are keywords? What are data types? Well, we're going to start by starting from the core syntaxes. Let's look at the syntactic structure. So what made up our syntax for what we type, what we type in our editor, and what are they made? What are they composed of? Now we are going to be talking about the keywords behind the defiers, the punctuation, the semicolon, the literals, that are the constants. Also look at the reserved word and also any form of language vocabulary, so and identifiers. Now let's look at some of the syntaxes and the data type. What do you mean by data types? Data types are type of data that enable to know the kind of the type a data is. I mean, what kind of data are we entering? Are we entering an integer data? Are we entering a character, a floating or a decimal place numbers? So this data type enables to uniquely identify what category of data and where they belong to. And also it enables us to also use the size, the size allocated to each data types. So the size to occupy in the memory, which is the RAM. So we're going to also be looking at them, also the control flow statement, the if. So there are keywords. These are keyword use. All these keywords, this keyword, they represent something the functions to operate on. You can't just use this word anyhow. We want to use this word by all means. You have to add a special character to it. For example, this is our previous code. Let's check the second one. Like for example, let's just call this P2. Just see. Now, our starting point is what include all our input output, standard input output library. Once we include that, our default main, we put it without putting anything in the parameter list. Then we return 0 by D now. Then here now, there's nothing going on here now. Remember, our program is automatically saved. We check it, auto save. So we don't need to be pressing Ctrl X to save the program. Then you will say, okay, int, these are int. And you see the keyword change with the help of the installed library compiler we installed. So you want to use this thing by promise. Enable us to tell us that, okay, this is age of a person. Maybe you are 23, for example. The semicolon enables us to what this is the end of the expression. You can also have under program again be number of ints, number of children. Then you can also have it, maybe you have it 2 plus 2. You can also still have it on the same line. For readability sake, you can just break it down into what? Into the separate line. This is a complete expression. This is it will now say something. Maybe if we want to check something is a boolean, maybe something is true or false. We use the keyword boolean, standard data type, understand, to check whether it is a boolean can take only 2 states, which is on and off, yes or no, or true or false. Then you can say, okay, as voted, understand, as voted now. This is what we call declaration. This is declaration. And it's a boolean. It's undefined. Again, something come. I will just check the state. Come, let me look at the type here. I see why it's saying bool is undefined. Okay, I still going to import other libraries to make it work. Some of those libraries are not like C++, where you have all those inbuilt all those functions working automatically from the standard input output. So that means it's not part of the standard input output functions. So maybe it's age or this or that. This will tell us the size of these. They are in bytes. You're going to see them in below in slide. You're going to see them the size. What is the size this int is occupying in the memory? Understand? These are keywords now. They tell us that you can only accept only integer number. Also want to accept the floating number, we use the float number or float number, maybe price of a go. Sometimes to indicate it, we put it's a decimal number. Sometimes we put F at the back of it. It works also in Java, the same way in Java. Also double can also maybe twice, maybe twice, for example, larger twice. Maybe this one is 8, 9 something. For example, this is just this double, right? Can you see the error of worker? You can see that if I miss something, there's an error showing here, right? There's an error here showing in front of it. You can just come to this your Views Marketplace and search for error lens. Error lens install. We just search for it and install it. So it enables your error to be shown by the right hand side. So it's showing that it's in this, expect this. So for my previous codes, I've not ended the expression. I need to end the statement. Now, then we continue. We continue. What's the PDF file? Okay, this is my PDF file. We have the storage auto static instant console. Maybe this size off. That inbuilt function is a what? And that keyword used to define custom data type. So I'm going to be seeing this one in case you don't want to have any negative. You know your age cannot be negative. You can easily put it here by default. Just your age. You don't expect any negative unsigned int here. So that means you are not expecting any negative number from this because int here by default the size of this is 4 bytes. So you can also make it 32 bytes. You can make it 60 bytes the way you want it. But let's still continue from the slide. Let's drop the gun. So let's just continue. Can you see? Relatively small set of keywords contribute to C, simplicity, understanding, and each push. So we have what it means here. We have few keywords here, unlike C++ or other higher programming languages. We have more keywords and data type there. So we have the constancies, the name, program entity, variable functions, structs. I'm going to be knowing this to create an object. We're going to know this thing in future. So just gradually we need to proceed to know these things. And the escape sequences, our new line, our /n, our /t for tab. We have seen /t for tab for new n, our not 0 for so /0 is always be at the end of the. There should be slash here because the later can chop it up because of the have to escape it as well. So /n, this should be /n for new line, /t for tab. Also, it's the same thing in all programming languages, especially except this ones, which is /0. It's not the same. It's only in C we have /0 that tell us a non-label terminated. We call this terminated string, non /0. So there the constancies and the punctuation marks and see to start statement. We need to start terminate a statement. Use semicolon to do that. But this is for block. And you see, this is for statement here. Terminate a statement here. Understand? Even though you have int, maybe you have int A, B, then you terminate it here like this. You have to terminate it so that A and B are declared as integer. I can assign as multiple to be what? To tell you that, oh, A and B are both integer. Right? So we'll terminate this here with the semicolon as well. Then we move here. Can you calibrate for arrays to indicate that something is array? We want to create a set of element numbers. So you have to use the square braces or char for character, this is for pointer, for address, or for references, and for preprocessor. You can see we are using the pants here for preprocessor here. Can you see the pants here? For preprocessor or divine constants. So variable argument list, you can use this one. Can you see? So we're going to see some of these things so to know them, but then you know that we are talking about them in the slide. So we cannot teach everything now so that we won't jump, we will be confused. But let's pick it gradually to address the problems. We pick the one we need to address our problems before we know other ones. Gradually we know everything. We know virtually everything. Sorry. So also for iteration, we want to perform declaration of statement, you can use int to declare as we are seeing. Int, or maybe you can also include the library called string to declare a string. You can also use char by default to declare a character or the name of someone. For example, we want to declare a character, there's no string there. Maybe the name of a person. So you go, string is a combination of character. So you can have character here and name. Okay, name of that person. Just give it here like this. The name of the person is what? Frederick. As a Frederick. As a maybe so this is to end it here. We have it here. So if we don't put the number of character here, it will automatically be calculated for you. Understand? So I'm going to check all these characters before I'm going to know them, the size they occupy. Understand? So we have the iteration, we have the comma block. This one for open braces and close braces. You can see here from open braces and close braces here. So we also have our selection statement for if else. That's control statement. I'm going to be doing that in control statement. Iteration loops, repetitions, jump to transfer, condition, continue, go to, or return. So jump to continue. We're going to see them with example in data that the concept of forms, foundation of C program, data types, operator, input IO. So three core concepts form the foundation of C programming language. So we have the data types. What kind of data are we expecting? The kind of operator or the operator we're going to use. What kind of operation we want to use? So operator will tell us the kind of operation we want to use and carry out those things. Then a thorough understanding of data types and operator is crucial. Yes, we know. So we got to know the kind of data we are working with before we can carry out any computations on them. The kind of data, the size of the data. Then we have the character, single character here, but multiple string, multiple character. Sign character granting sign small integer from -128 to 127. If you add these two numbers, that means sign character means what? It's an 8-bit. If you add these two together, you are going to get an 8-bit. 128 to 0 is what? 128 to 0, from 0 to 127, making 256. Understand? So the same thing here, we have unsigned char. Unsigned char is also from 0. It's not taking any negative values from 0 to 256. Just a 2 raised to the power n. Any of those things, that's 2 raised to the power n, 2 raised to the power n minus 1. So it's starting from 0 to 255. So standard integer numbers, like 16 bits, short int. Short int is 16 bits. How do we know that it's 16, often 16 bits? Let's know maybe whether it is 16 bit or not. Let's check them out. We check them out here. We have int here to be 16 bits. But let me remove this first. Now let me point out the type. Maybe point out. Let me point out the point f. So let me point out the size of data in bytes. So then we have we use size of to check it. Size of is a keyword, is a function. If you take in that card, the character we're talking about, let's look for age now. Let's check age. For example, we can also check the int as well. Let's check age. Let's compile. And let's run it here. Can you see? It's telling me 4 bytes. So 4 bytes. 4 bytes means 4 times 8. 1 byte is 8. So 1 byte is 8 times that's 1. Sorry, 4 bytes is 32. That is 8 bits. 1 byte is 8 bits. 8 times 4, that is 32. So that's why we have 4 bytes. So we have this one in byte. You can also put it in. You can also put int here. Understand? So sometimes you can see, you just see two sometimes. So you can see what you see. You see int, but let's put short here. Let's now put short in front of it. Then now check for age. So then you can also run it here. What do you have here? I think we have 2 bytes. 2 short is 16. So we have in our slide here, we have what? 16. So we're able to get that now. I will put it here in case you want to check for int alone. Because okay, short int. Put inside the function together. So let's run it. What do we get here? So we have what? You see 2 bytes. See 2 bytes. Now therefore, let's continue. Let's continue with standard integers. So we have to check for the standard integer values. So we have this. So you can check the same thing for all these. For all these, you have long ints, 32 bits. You can also do for the long. You can do for the other ones. So then the float single, the precisions for good for speed, memory, for consistency. Float for in case of prices, want to do with decimal numbers. So you should be able to know them. Long double, etc. You can see, just demonstrate them. I'm going to demonstrate them. So C, C++, so in the year 1999 versions. But here now, I think the owner is 2023 versions. Come to our version, what version? GCC 2025. This one is 2025. You can see I'm having 225, 25 something. This is the year. So 04 2025. This is the update of the compiler. So I mean, I see C++ 20 upwards. So that's the version I'm using. So now, so you can see the void type does not have anything, does not return anything, does not do anything. Then we also have the built-in arrays, pointer, structures. We're going to be seeing here of this thing in the future. The keyword, alter, the basic types, sign or sign. When you want to deal with negative value, we use sign. You can put sign. We don't put sign there, so it will be assumed that the value is negative by default. So addition, multiplication, division. These are operators now. These are operators. Yeah, thanks. Sorry for the overlaps here. These are operators for add, for multiplication, for division, for modulus, modulus for checking the remainder. Understand? Now, if sometimes if I can just check the remainder of a program, you just check the remainder of this. Then let's just calculate the remainder. Okay, for example, let's just check the car. So you can also do the one for car and name as well. But just check the remainder on something. You want to check for the remainder of this. Let me just check the remainder. Remainder of remainder, that is 34 modulus 3, for example. That means it means 34 divided by 3 still give us the remainder. That is what we are expecting. So that should give us the answer. So what is the remainder of 34 divided by 3? So we have it's a 1. Why? Why is it 1? 34 divided by 3. 34 divided by 3. Okay, if we do 34 into 3 times, we have 11. So we still have 1. That is 33. So you still have 1, right? According to me, now make it 35. You should get like 2 remainder. So we should have this. We should have like 2 now. You see, we have this calculating the remainder of any program. You know, in our program, we do calculate the remainder. We use some binary division, something. You can get the remainder of what you are looking for. Then we have logical operators. If something is and or you want to check when this one is true or false, or the bitwise operations, I'm going to be seeing them in use. Because I don't want the video to be too long. So we see the increment operators. So I'm going to be seeing them. This is ternary operator as well. It's a single line condition to check something, whether it is. So now let me demonstrate this for us. For example, if we have a 5 plus 4, let me start from the no greater than 5. Okay, let's do from the greater than and less than. Now let's check a and let's just give us a variables to work with. Let's just have int a equals to what? 5. Int b equals to what? Maybe 4, for example. If you want to check maybe something is greater than something, I'm going to talk about control statement later on. But just if a is greater than b, for example, it's less greater than b, then it should point out what? Greater. Maybe we'll just say okay. Let's just get the value of this. This is greater than this. So this is the placeholder to check the two integer value. That means we do it this way. N For the new line values, then we now say, okay, percent, that is A and B. We pass in the two value. Now we terminate this with this now. So we check whether something is greater than this or not. Then we let's see now. It said 5 is greater than 4, which is true. Also do the same thing for our bitwise operations. You can also do bitwise operations for bitwise operation, that is int, maybe maybe b. Let me call it bitwise. It just bitwise of A or B. Okay, what's going to be our answer here? Let's run it first. So I'm going to do the calculation. Okay, I'm not printing anything. Sorry, I'm not seeing. Then print visual result. So we have bitwise. Then we run it now. Let's run this. Let's run it now. We are getting 5. A or B. Bitwise result of A. Let's calculate it manually. 5 is 8.28 bits. 000 0010 0101. That is, and our 4 is 000100. So now let's calculate. Now our result. Let's do the bitwise OR operations. Bitwise OR operation. 1 and 0. This one is 000. So 01000. 1 and 0. 1. Okay, we'll start from here. Okay, this is just okay. 1 and 0 should be, this one will be 1. 0 0, which is 0. 1 and 1, it should still be 1. It will still be 1 0 1, which is still 5. We are right. So now let's I can also do the same thing for ternary operations. Instead of us writing this if operations here, or this command greater, let's just limit as greater to check whether something is greater than or not. Using the ternary operator to check what is it. This also the same thing for this logical operation. Let's use the ternary operator. Let's also use this ternary operator here. I'm going to be seeing some of this one in the future videos. I'm going to be seeing them. Just use the common ones. Now let your A. If A is greater than B, if A is greater than B, question mark is where it comes in. If A is greater than B, it's a question mark, just like English. A is greater than B, then you report that you return A. S, you return B. So let's do it this way. Understand? If the one is greater now, then let's print out greater. Greater value. Understand? Now let's try to check it now. Greater value between this and this. So that means is this. So I have to firstly put what? Put the first one, maybe greater than which is A, comma B, comma. Then I'm doing this just for us to see how you can maybe our output display printf format. So now let's run it here. Just run it here. Can you see? The greater value between 5 and 4 is 5. Can you see? We get the value set. So a single line condition statement. So now, since you can also try, I'm going to be demonstrating them for logical operation. Okay, for example, I just want it to involve more logic if control statement of which we have not talked about. So in the next lecture, we explain better on all those things. We also later on will be practicing some exercises. Though we are going to have some exercises. So thank you very much. Please like, subscribe, share. See you in the next video. Bye-bye.